Hello, my name is Nathan Nguyen, and I'm an undergraduate student in Dr. Heather Hanga's Vascular Mechanobiology lab. Today, I'll be going over our poster titled, A Review on the Progression of Atherosclerosis. Before we start, let's answer the following question. What is atherosclerosis? Atherosclerosis involves the narrowing of blood vessels through the accumulation of lipids, macrophages, foam cells, and calcium over time. One of the main objectives in our lab is to assist in the prognosis of this disease. We are developing an agent-based model, or ABM for short, that will simulate molecular and cellular interactions to predict arterial growth and remodeling. One particular area that has not been heavily explored is vascular calcification, which is commonly known as VC. What is presently known about VC is that it involves the hardening of plaque, which may promote arterial narrowing. However, there are still several questions regarding its origins and progression. Furthermore, the only known way to evaluate its growth is through calcium scoring. However, that requires the use of CT scans and X-rays and is only primarily used as a clinical indicator for heart attacks. Therefore, in this presentation, we hope to address potential origins of vascular calcification, the biological interactions involved with this advancement, and a way we can quantify and apply these interactions into our model. To start off, I would like to discuss our methodology in conducting this research. To draw our conclusions, we utilized a three-phase literature review process. First, we did an initial review where we would individually take notes over different papers. From there, we would go into a discussion phase where we would exchange notes and ideas about those publications. And lastly, we would conclude by doing an in-depth analysis of each publication. This would include reviewing supplementary information, plotting data, and attempts to derive equations to quantify interactions. Using this methodology, we were able to make several interesting connections. One of the first things we saw was that 75 to 88% of vascular smooth muscle cells contributed to vascular calcification. These VSMCs contribute to calcification following two pathways. The first pathway involves VSMC's high affinity towards phenotypic transformation into several different cells, including macrophages, foam cells, adipocytes, etc. What is most relevant to calcification, though, is their ability to transform into osteochondrogenic cells. These cells can enhance osteogenic activity, which may subsequently increase calcification. The second pathway that contributes to calcification is through VSMC apoptosis. Studies have shown that intracellular compartments of VSMCs, such as endoplasmic reticulum and cytoplasm, contain calcium, and when these cells die, the calcium is released and vascular calcification worsens. Now that we knew how calcium forms, we wanted to look at what influenced the pathways. Regarding osteochondrogenic cells, we saw that there was a relationship between hormones and osteogenic activity. Studies have shown that testosterone is more likely to increase risk of vascular calcification, whereas estrogen is more cardioprotective and inhibits VC. And this relationship makes sense, as women are less likely to develop atherosclerosis. Next, regarding VSMC apoptosis, other studies have noted a variety of different influencing factors. However, for this presentation, we aim to highlight four interactions: macrophage VSMC proximity, tumor necrosis factor alpha, nitric oxide, and shear stress. Each interaction mentioned has seen to induce VSMC apoptosis, and we found quantifications for each regarding how VSMC numbers may change. Considering we also know that VSMCs contain an intracellular calcification concentration ranging from 100 to 10,000 nanomolars, by coupling these quantities together, we can follow the pathway to determine a mathematical equation to simulate VSMC contribution to VC. Therefore, within this presentation, we have described the origin of vascular calcification and presented pathways for the progression of VC. A picture of our model can be seen in the conclusion section of this poster. With these findings, our future goals are to integrate them to our ABM to better refine our model and produce a better simulation. Thank you.